Hello everyone, welcome back to my YouTube channel. Today we'll be continuing our chapter that is sets. In previous part, we have discussed about what is set and the two methods of representing a set, roster form and set builder form. I hope you have watched the part 1 of the video. So if you haven't watched, the link is in description, do watch it. Let us move to today's session. In today's session, we will discuss about types of set. So basically, there are 5 types of set. First one is the empty set or null set. Second one is a singleton set. Third one is finite set. Fourth is infinite set and equal sets. So we are going to discuss in detail about these types of set. Let us discuss about empty set or null set. So from the word itself, it is clear that empty set or null set means such a set in which there is no element. That's why it is called empty set or null set. If there is not a single element in the set which satisfies the given condition, then it is called a null set or an empty set. Null set is represented by symbol phi, or you can represent simple curly braces without listing an element there. So in both the ways, you can represent the empty set or null set. For example, B is equal to, now here the set is given in the set builder form. How we can read it? The set of all x such that x is a student presently studying in both classes, 10th and 11th. Now they have given a set such that the student is studying in both classes, 10th and 11th presently. So if you read this set, we observe that student cannot study simultaneously in both the class 10th and 11th. So that's why there is no element in set B. So set B can be a null set. One more example. The set of all x such that x is a natural number between 2 and 3. Now we know that between 2 and 3 there is no natural number. Natural numbers are counting numbers. So after 1, 2, then after 2 there is 3, after 3 there is 4. Between 2 and 3 there are no numbers. So again this set B is nothing but a null set or empty set. Let us discuss now what is singleton set. Now from the word itself, singleton means it has single element inside it. So a set consisting of single element is called a singleton set. For example, A is the set of even prime numbers. Now only even prime number in the number system is 2. So our set A is a singleton set as the only element present is 2. Only one element is present. E is equal to set of all x such that x belongs to natural number and x cube is equal to 27. Is a singleton set with a single element 3. Because only the cube of 3 is 27. No other number than 3, the cube gives us 27. Let us move to the next concept, finite and infinite sets. So if a set is a null set or number of elements are limited and countable, then it is called a finite set. If it is a null set or elements are countable, then we consider it as a finite set. If the number of elements is unlimited and uncountable, then the sets are called as infinite sets. Let us see some examples. Let W be the set of the days of the week. Now days of the week, there are only 7 days of the week. So they are countable, right? So it is a finite. So W is finite set. Let S be the set of solutions of equation x square minus 16 is equal to 0. Now equation is x square minus 16 equal to 0. So what will be the value of x here? So if we solve the equation, x square will become 16 and x will be equal to, if you take the square root, it will be 4 plus 4 or x can be minus 4. So there are only two values possible of x. There are only two values of x which are possible, 4 or minus 4. So this is a finite set. Next example, let G be the set of points on a line. Now, there is a line and G is a set of points. Now, if I draw a line here, I can draw infinite number of points on a line. So there can be infinite number of points on a line. So therefore, our set G becomes infinite. Okay. Next, let N be the set of natural numbers. Set of natural numbers that are counting numbers. So 1, 2, 3, 4, 5, and it will go on till infinity. So again, the set of natural numbers becomes our infinite set. So I hope you understood difference between finite set and infinite set. Let us discuss about the next type of set, that is equal sets. So two sets A and B are said to be equal if they have exactly same elements and we write A is equal to B. Otherwise, the sets are said to be unequal and we write A is not equal to B. For example, see the first set A. The set of all x such that x is a letter of word listen. So x is nothing but letter of word listen. So how many elements are there? L, I, S, T, E, N. So these 6 elements are there in the set A. L, I, S, T, E, N. Now let us see the second set, set B. Set of all y such that y is a letter of word silent. So what will be the elements of the set? S, I, L, E, N, T. Now here you can see in set A the element is L. Also in set B there is element L. In set A there is element I. Also in set B there is element I. In set A there is element S. Also in set B we have element S. In set A there is element T. Also in set B we have T. In set A the element is E. Also in B we have the element E. And the last element N there is in set A, also in set B. So you can see that each element of set A is present in set B. So both these sets are equal. Now here order doesn't matter. We have already learned in sets. The order of element doesn't matter. But you can see, observe here, all the elements are present in set A and set B are same. So set A and set B are said to be equal sets. Now, take a next example. Let A be the set of prime numbers less than 6. So prime numbers less than 6. So what will be my elements there? So 2, 3, 5. So this will be my 3 prime numbers less than 6. And P be the set of prime factors of 30. Now let us find the prime factors of 30. So 2 ones are 2, 2 fives are 10, 15. Then 3 fives are 15, 5 ones are 5. What are the prime factors of 30? 2, 3 and 5. So the set P elements are 2, 3 and 5. So by observation we can see the elements present in set A and the elements present in set P are same. In both the sets we have 3 elements and all the 3 elements are same. So these sets are equal sets. Since 2, 3 and 5 are the only prime factors of 30 and also these are less than 6, then we can say that set A and set P are equal sets. So I hope you understood the types of set, what are null set, what are singleton set, finite set, infinite set and equal set. Based on this theory, now we will solve the practice set 1.2. So let us solve the practice set 1.2. This is your question number 1. Decide which of the following are equal sets and which are not. Justify your answer. Now from this A, B, C, there are 3 sets given. We have to decide which of the following are equal sets and which are not equal sets. So first, before deciding our equal sets, we'll first write those sets in a listing method or roster form so that we will come to know what are the elements present in the set. So let us come to the first set A. Now, what is set A? Set of all x such that 3x minus 1 is equal to 2. So in the first set, what will be my elements present? So first we need to solve the equation. 3x minus 1 is equal to 2, which means 3x is equal to 2 plus 1, that is equal to 3. So x will be equal to 3 upon 3, that is 1. So the value of x is 1. So only one element is present in my set A, that is 1. So this is a which type of set? Singleton set. Now let us solve the set 2, that is B. Set B. Set of all x such that x is a natural number, but x is neither prime nor composite. Now we know that a number which is neither prime nor composite, which is that number? It is 1. So 1 is the number which is neither prime nor composite. So again, my element is 1. This is also a singleton set. C. Set C. Set of all x such that x belongs to natural number and x is less than 2. X is less than 2 and natural number starts from 1. So which number is less than 2? 1. So our set C, the element becomes 1. Now from these three sets, what we can have a conclusion. So we can say that set A, set B, and set C are equal sets. Why equal sets? Because the element present in each of the sets is same. So therefore, our set A and set B and set C, all the three sets are equal sets. Okay, I hope you understood how we come to the conclusion that all the three sets are equal set. Now let us move to the next question. Question number 2. Decide whether set A and set B are equal set. Give reason for your answer. The same thing we have to do. First, we need to find the elements of set A and set B. Then we have to observe whether they are equal sets or not. So let us find the elements of set A. So here, set A is equal to even prime numbers. So what are the even prime numbers? We have only one even prime number, that is 2. So set A is nothing but equal to 2. Only one element is there, that is 2. Second, set B. Set of all x such that 7x minus 1 is equal to 13. So we need to solve the equation 7x minus 1 is equal to 13. So 7x will be 14, 13 plus 1, 14. So x will be equal to 14 divided by 7, that is equal to 2. So again, we are getting the element 2. So by observation, what we can write? Set A and set B are equal sets because the elements present in both the sets is equal, that is 2. Now let us move to the next question, question number 3. Which of the following are empty sets and why? So now we need to decide which of the following sets are empty sets. Empty sets means the sets in which there is no element present. There is no element present. Empty set is also known as null set. So let us find. Question number first. A is equal to set of all A such that A is a natural number smaller than 0. So first question. A is a natural number smaller than 0. Now natural number starts from 1. So is there any natural number smaller than 0? No. So a set A is null set. You can represent it at like this also. You just need to put the braces and writing no element, or you can write symbol of phi. Anyway, you can represent. So a set A is a null set. Second, B is equal to set of all x such that x square is equal to 0. X square is equal to 0. Now, is this a null set? No, it is not a null set because, see, if x square is equal to 0, then x is equal to 0. 0 square is 0. So 0 is the value of x. So I can write 0 is the value of x. Now 0 is certain value. In empty set means there is no element, but here we have got the value of x as 0. So 0 will be considered as an element. It is a value. So 0 is an element. So set B will not be an empty set because there is an element present in the set A, set B. Okay, let us move to the third question. C is equal to set of all x such that 5x minus 2 is equal to 0 and x belongs to natural number. Now, let us solve the equation 5x minus 2 equal to 0. So 5x will be equal to 2, x will be equal to 2 by 5. Now x is equal to 2 upon 5. This is a decimal number, or you can say fraction. This is fraction. But in question, you can see x belongs to natural number. Second condition is but x belongs to natural number. Therefore, our set C will be a null set because there will be no element present in set C. Can we write here 2 upon 5? No, because 2 upon 5 is not a natural number. It is in fraction. It is a real number, but not a natural number. It is a rational number. So we cannot write the element here 2 upon 5. So set A and set C becomes our empty set, while set B is a singleton set, because in set A and set C there are no elements present. In set B there is element present, one element present. So I hope you understood this. Now let us move to the next question then. Question number 4. Write the reasons which of the following sets are finite sets or infinite sets. Let us solve the first question. A is equal to set of all x such that x is less than 10 and x is a natural number. So first we'll write the set in a roster form. So what will be my elements in set A? So x is less than 10 and it is a natural number. So natural number starts from 1. So my set A will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. We will not include 10 because it is less than 10. So this will be my sets. So is this a finite set or infinite set? It is a finite set as we can count the number of elements. So how we'll write the reason? Set A is a finite set as the number of elements are countable. Okay, let us move to the next question. Question number 2. B is equal to set of all y such that y is less than -1 and y is an integer. Okay, now y is an integer and it is less than -1. So less than -1 means -2, -3, -4, -5 and so on. So our set B will become -2, -3, -4 and it will go until infinity because they have not mentioned the ending value. They have just mentioned less than -1. So our set B will be, set B is a infinite set. And what is the reason? As we cannot count the elements. Let us move to the third question. C is equal to set of students of class 9 from your school. Now, can we count the students of class 9 from your school? Yes. So it is a finite set as we can count the number of students of class 9. So what reason we will write? Set C is a finite set as we can count the number of students of class 9. Let us move to the fourth question. Set of people from your village. Is this a finite set or infinite set? Finite set because we can count the number of people living in a village. It is a finite set as we can count the number of people living in a village. Let us move to the fifth question. Set of apparatus in laboratory. This is also finite set. We can count the number of apparatus in our lab. So it is a finite set. As we can count the number of apparatus in the laboratory. Sixth question. Set of whole numbers. Now whole numbers we denote usually by W, capital W. What are set of whole numbers? 0 and natural numbers. 1, 2, 3, 4 and so on. So this will be an infinite set as if elements are not countable. We cannot count the number of elements. So the set of whole numbers is infinite set as we cannot count the number of elements in it. Next, question number 7. Set of rational numbers. So again, set of natural numbers. It is an infinite set because in rational numbers, we have natural numbers, whole numbers, integers. So all these three types of numbers are included in rational numbers. So set of rational number is also infinite. So set of rational numbers is infinite set as we cannot count the elements. So I hope you understood how we classified the sets as finite or infinite set. Here we have completed practice set 1.2. Now we will solve some extra problems related to types of sets. Which of the following are examples of null set? So there are 4 sets given. We need to find which of the following is example of a empty set or null set. First example. Set of odd natural numbers divided by 2. Set of odd natural numbers. So it is divisible by 2. Now the numbers which are divisible by 2 are nothing but even numbers. But we need odd natural numbers. So there is no such odd natural number which is divisible by 2. So a set A will be a null set. So first set becomes a null set. So this is an empty set, or you can say null set. Second, set of even prime numbers. We know set of even prime numbers, it includes one even prime number, that is 2. So this is not an empty set. It is a singleton set. Let us move to the next question. The set of all x such that x is a natural numbers, x is less than 5 and x is greater than 7. Now, let us say x is less than 5. So let us consider 4. 4 is less than 5. But is it greater than 7? No. Then 3 is less than 5. Is it greater than 7? No. So there is no number which is simultaneously less than 5, also greater than 7. If you take 6, 6 is less than 5. No. It is greater than 7. No. If you take 9, it is greater than 7, but it is not less than 7. We want both the condition to be fulfilled. Less than 5 also and greater than 7 also. There is no natural number which is less than 5 also and greater than 7 also. So our set C or the third set will becomes an empty set or null set. Let us move to the next question. Set of all y such that y is a point common to any two parallel lines. Now do any parallel lines intersect each other? For a common point, the lines should be intersected. but parallel lines never intersect each other. So there will be no common point. So again, our last set will be also a empty set. Let us move to the next question. Which of the following sets are finite or infinite set? The set of months of a year. Now we can count the set of months. We can count the months of the year. So it is a finite set. So first set is a finite set. Next, 1, 2, 3 up to infinity. Dotted lines represent up to infinity. So this is not countable. So this is an infinite set. Next, 1, 2, 3 up to 100. So these numbers are countable. 1, 2, these are natural numbers less than equal to 100. So this is again a finite set. Set of positive integers greater than 100. Positive integer greater than 100 means 101, 102, 103, and so on. So again, this is an infinite set. Next, set of prime numbers less than 99. So this is also a finite set because from 1 to 99, which are prime numbers that we have to write, and those are countable. So again, it is a finite set. Set of lines which are parallel to x-axis. Now, what is this? If this is our y-axis and x-axis. Lines parallel to x-axis means these are the lines parallel to x-axis. So here I can draw infinite lines which are parallel to x-axis. So again, this will become our infinite set. This will be our infinite set. Next, set of letters in English alphabet. This is a finite set because we have 26 letters in the English alphabet that are countable. So this is a finite set. Next, set of numbers which are multiple of 5. Numbers which are multiple of 5, that are 5, 10, 15, 20, 25, 30, 35, it will go on till infinity. So again, this is our infinite set. Last, set of circles passing through the origin 0, 0. Passing through origin 0, 0. For example, this is our graph, this is our origin, this is our origin. So how many circles can pass through origin? N number of circles can pass through origin, right? So again, the set of circle passing through origin is our infinite set. So I hope you understood how we classified the sets into finite set and infinite set. So let us move to the next question. Question number 3. Are the following pair of sets equal? Give reasons. So they have given us pair of sets. First question, A is equal to 2, 3. Okay, they have already given us in the roster form. Elements are 2 and 3. Second, B is equal to set of all x such that x is a solution of x square plus 5x plus 6 equal to 0. Now here they have given us quadratic equation that we have to solve. So x square plus 5x plus 6 equal to 0. Now this is a quadratic equation and we need to solve the quadratic equation. In 8th standard, you have learned how to solve a quadratic equation. So first we need to find the factors of 6. 3 to the 6 and 3 plus 2 will give you 5. So write x square plus 3x plus 2x plus 6 equal to 0. So we'll take common factor from here. X is a common, x plus 3. Plus 2 is common, x plus 3 equal to 0. From here we get x plus 3, x plus 2 equal to 0. So either x plus 3 equal to 0 or x plus 2 is equal to 0. So I'm getting the value of x as -3 or x is equal to -2. I'm getting the two values -3 and -2. So my set B, what are the elements? -2 and -3. So are they equal sets? No. In the first set, the elements are 2 and 3. In the second set, the element is -2 and -3. So my sets are not equal. Set B is -2, -3. Let us move to the next question. Set A is equal to set of all x such that x is a letter in the word follow. So how many elements will be there? F, O, L, W. This will be my 4 elements. And in set B, Y is a letter in the word wolf. So W, O, L, F. So as you can see, F is present, O is present, L is present, W is present. All the 4 elements are same. So set A and set B are equal sets. So these are equal sets, as the elements present in the set A and set B are equal. Okay. So I hope you understood how we have classified the sets into equal set, infinite set, finite set. So this is the end of today's session. I hope you found this video interesting. So do like, share and subscribe our channel. Thank you.